All right, so we are looking at graphing inequalities because remember this unit is about um, linear functions, and inequalities can be used using function notation. All right, so let's take a look. This is the homework assignment. Okay, so I'm gonna do a majority of the problems, and then you guys will be required to finish it. So it's asking for the inequality, all right? So it's the inequality represents the line and the shaded region, all right? So I'm going to start with f of x because that's what it's labeled. It's labeled f of x. I'm going to write f of x. Okay, I don't know why it does that, why it has that sort of aura around it. I don't like it though. Okay, now the next one's either going to be, it's either going to be a less than, a greater than, a less than or equal to, or a greater than or equal to. Okay, so it's one of these four. So here's what you do. First, you look and see that it's a solid line. If it's a solid line, then it's going to have the equals to because it includes the line as part of the solution. If it was a dashed line like number 2, then it doesn't have the equals to. It's an inequality like this. It's one of these two. So I know it's going to be one of these two because it's a solid line. And then I look at it and say, okay, where is the shade? If I was on the line, if I was standing on the line, I'm standing on there, and I wanted to get to the shaded region, would I move up or would I move down? Okay, and I would move down. So that's why it's a less than. Down is less than. So it's going to be this one, less than or equal to. So f of x is less than or equal to. And then I'm going to do mx plus b. So I need my slope. So my slope is up to, right to, which is positive 2 over positive 2, which makes 1. So I'm just going to put x, because it's 1x. And then my y-intercept is right there at negative 2, so I'm going to write negative 2. So my inequality is f of x is less than or equal to x minus 2. Now, what is the solution? So a solution is represented by anything in the shaded region as in conjunction with anything on the line. Okay, so anything on the line or anything here. Only reason why anything on the line is a solution is because it's a solid line. So anything on this line would not be a solution. That's telling us, hey, you cannot include anything on the line. So I don't know. I mean, I'll pick anything. Maybe I'll just pick this one, that point right there, which is 2 comma negative 2. Okay, so there's a solution. All right, so let's look at number 2 now. Again, my function is f of x. So I'm going to start my inequality as f of x. And then it's going to be one of these, and I talked about how it's a dashed line. So I know it's going to be one of these two, not these. So it's going to be one of these top two. It's either going to be less than or it's going to be greater than. Well, if I'm on the line, standing on the line, and I wanted to get to the shaded region, I would go down, directly down. So that's a less than. Okay, so then I need mx plus b, so I need my m. So that's up to and right 1. All right, so that is a slope of up 2 is positive 2, right 1 is positive 1, which actually gives me 2. So I'm going to put 2x, and then this is negative 1, so I'm going to put a minus 1 here. Okay, what is the solution? Anything in the shaded region again? Anything, it doesn't matter. I don't know, I'm just going to be tricky and I'll put something right there. So that's 0, negative 1, 2, 3, 4. So 0, negative 4. Okay, and it's asking, is 2, 3 a solution? Let's see. So 1, 2, 1, 2, 3. Is this a solution right there? On the line, is it a solution? What do you guys think? On the line, is it a solution? I've talked about it. Okay, and remember it's a dashed line, so anything on the line is not a solution. Okay, so no, it's not. Okay, let's jump over here to number 5. Okay, so let's write the inequality to this. Now, this is a constant function. These should be easier. Those constant functions should be easy. You don't have to think about mx plus b. You just know it's just going to be g of x and then an inequality with a number. So this one again is labeled g of x, so I'm going to write it as g of x. Now, it's a dashed line, so it's going to be one of these two. And it's shaded below. It's underneath. Okay, and sorry, each of my examples has been a less than, but hopefully you guys kind of get the hang of it from what I'm talking about. So this is going to be less than because it's below. There's no equal sign because it's not a solid line. And where is it crossing? It's crossing at negative 1, 2, 3. So what is the solution? I don't know. Maybe I'll come over here. 1, 2, 3, negative 1, 2, 3, 4. So 3, negative 4. Provide a coordinate that is not a solution to g of x. You can choose any point on the line. You can choose, I would just choose the origin because it's easy. I would just say 0, 0. Right? So the origin is not a solution because it's not part of the shaded region. Okay, now if we were doing number 4, if I'm standing on the line, I would be moving up to get to the shaded region. Up, so that is a greater than. It's a solid line, so this one, I'm just going to start it for you guys, is greater than or equal to. That's how that's going to be. Okay, and then you could do the mx plus b. Don't forget your m is, I'm just going to end up doing it. So down, right? M is going down 1, 2, 3. So down 3, which is negative 3. And then right 1 is positive 1, which of course reduces to negative 3. So that is negative 3x. And then my y-intercept is 1, 2, 3, so plus 3. What is the solution? Again, anything here or even on the line. So I'm just going to choose this one right there, 1, 0. I'm going to say 1, 0 is a solution. And then is 2, negative 3 a solution? So 1, 2, 1, 2, 3. That's on the line. And since it's a solid line, yes, it is. If it was a dashed line, I would say no. Solid line, yes, sirree, Bob. Okay, so you guys have 2 to do on your own right there. Big deal. Okay, so now 7, 8, and 9. I just wanted you guys to see this. So if you're graphing and it's not in slope-intercept form, okay, we're actually going to have to put it in slope-intercept form. So to do that, I need to move the x over to the other side. So I'm just going to move it over here. So I've got negative 4y, and then I've got greater than or equal to. And when I bring this over, it becomes a positive 2x. And then I still have this minus 4. Okay, and I need to get rid of this minus 4, or this negative 4, sorry. In this case, it's considered a negative 4. And I'm going to do it by dividing everything by negative 4. Divide that by negative 4, divide that by negative 4, and divide that by negative 4. Okay, so this reduces to 1. Okay, but we got to be careful here, because now that anytime you multiply or divide by a negative in the equation or inequality, you need to flip the sign over. This gets flipped over. So that's the little trick thing, the one thing I want you guys to remember. So I'm going to flip it over. It becomes a less than or equal to. And then 2 over 4 is 1/2, but with a negative. So negative 1/2 x. And then negative 4 divided by negative 4 is positive 1. Okay, so this dividing by negative 4, that caused us to flip the sign over. Okay, so now let's graph it. So I start at 1, right, because my b is 1. Oops, sorry, it's right there. There's my 1. And then I'm going to go down 1, right 2. Down 1, right 2. Down 1, right 2. Or I can go up 1, left 2. Up 1, left 2. And it's a solid line, so I'm going to draw a solid line. I know some of you actually use the tools here to draw a line. Let's see. Let me try to do that. Maybe I'll draw a line here. Insert a line. I want it the same color. Okay. And then I'll end up drawing the rest of it like that, because it's a line. It goes indefinitely in both directions. You have to draw it like that so that it shows the arrowheads. Otherwise, you've just drawn a segment. Okay, so this is a line. And we have to do the inequality now. So it says y is less than or equal to. So we've got the equal to with the solid line, and now we just need a less than. And again, if I'm on the line, less than is underneath. So I'm just going to go ahead and just show my shades by drawing lines going down. If you want to just kind of color it in that way, do what you want, but I feel like it just kind of looks a little more neat the way I did it. Okay, so there's the inequality. Okay, and then for number 9, right, if you want like an example to see for number 9, you can look at number 5. Okay. Oh, and well, this one's not, it doesn't show the function, it's a y, so I don't have to label it f of x or anything. But number 9, you should label it. Okay, and then this next set here, what we're doing is we're looking at a system which is more than one inequality. So we'll just do one at a time. Okay, so I'm going to do f first. So I've got f of x, and it's, if I'm on the line, the shaded region is down here. I don't worry about it down here because this is cut it off because it's above this one. So I just look at that part of the line of where the shaded region is, and it's underneath it. So it's less than, it's a solid line, so it's less than or equal to. And then I need the mx plus b. So my m is down 1, right 1, right, which is negative 1 over 1, which equals negative 1. So I'm going to write it as negative x. And then my b is 1, 2, 3, so plus 3. Now let's do g of x. So g of x is not a solid line, so it's not going to have the equals underneath. The shaded region is above, so it's greater than. And my slope, I'm going to use these points. I know sometimes when it's dashed, it's hard to tell what the points are, but there's a point here and a point here. So that's up 2 and right 1. So that's 2 over 1, positive 2 over positive 1, which equals 2. So this is going to be 2x, and then it's at 1, 2, 3, 4, minus 4, like so. Okay, and then I'm just going to put this just to keep it as a set. Okay. 11 should be should be easier, okay, because we have a constant function. So I'm going to do, I got the f of x first. So I'm going to do f of x. And it's a solid line, so I know it's going to be an equals to. It's shaded underneath it, so it's going to be less than or equal to. And then my number, my constant number is 1, 2. It's 2, because the y value is always 2. So there's the 2. And then h of x, again, if I'm standing on the line and I wanted to get to the shaded region, I would go down. It's a dashed line, so it's just less than. Okay? There's no equals to. It's less than because it's shaded underneath. And then my slope is down 1, right 1, which we did here, same thing, is negative 1, which we just say is negative x. And then the y-intercept is 0. I don't put a plus 0. It looks just like this. Okay, so that is my set. All right, but if you come over here to 13, we actually have 3 functions. Okay, so we've got f, so I'm going to start with f of x. And it's, if I'm standing on the line, it's above it. You would go up to get to it. If you went down, you're down here. But it's up, it's above it. So it's greater than or equal to because it's a solid line. So there's the equal to. And my slope, I need 2 points. So I'm going to choose this one and this one. So down 2, right 1. Down 2, right 1 is negative 2 over positive 1, which is negative 2. And my y-intercept is right here at negative 1, 2, 3. And then I've got g of x. And g of x is a dashed line. And if I'm standing on the line and I wanted to get to the shaded region, I would go up, up, up here. So it's greater than. Okay. It's a dashed line, so there's no equals to. I need my slope. I know it's going upwards. So I know it's a positive slope. So up 1, right 1, which is 1 over 1, which is 1. So it would be 1x or just x. My y-intercept is 1, 2 at 2. And then we have ourselves a constant function. I like that. So h of x is shaded underneath. And it's a dashed line, so it's less than. And it goes through at my constant number is 1, 2, 3, 4. Okay, so my y value is always 4. And there it is. So really, I mean, it's not hard at all. Okay, now 14 is a little different because of this function or this non-function. It's a vertical line, but I just wanted you guys to see an example of writing the equation for a vertical line. So a constant line starts with like it's like a y equals 4, or like this case it's an inequality, so it's y is less than 4, but it's really h of x. Well, this one here, you can't label it as with function notation because it's not a function. But vertical lines start with x, so x, and then shaded. It's shaded to the right, and everything to the right of this 1 is bigger than 1, so it's greater than. And it's a dashed line, so there's no equals to. So x is greater than 1. And then g of x shaded underneath it. Okay, and actually that should be shaded too, right there. But there's only 2 of them. Okay, so g of x is shaded underneath it. So g of x is less than or equal to my m, let's see, I'll use this point and that point. This point and that point. So I'm going to go up 2, so that's positive 2, over right 1, 2, 3. So 2/3 x, and that's minus 2. Just like that. Okay? So you guys have 12 and 15 to do. Okay, so just know that this one is shaded underneath. This one here, so this one here, shaded above. And then this one, it looks like it's not part of it, but it's shaded underneath it. But then this cuts it off and makes it shaded underneath that. So this is underneath, so it's below. So that one would be a less than. Okay, so it says which graph represents that inequality? Well, I need to do a little bit of work, so I'm going to move this over. So I have negative 18y is less than or equal to, that becomes a negative 6x minus 36. And then I need to get rid of that negative 18, so I'm going to divide every term by negative 18. So these reduce to 1, so I've got a y. Because I divided by a negative, I got to flip the sign over, so greater than or equal to. And then negative divided by negative is a positive. 6 over 18 reduces to 1/3 x. And then negative divided by negative is a positive 2. So I needed to cross at 2, have a slope of 1/3, and be shaded above. Okay? So I already know it's not this one because this is shaded below. So this one has a y-intercept of 2, up 1, right 3, up 1, right 3, it's shaded above. This one has a y-intercept of 6 and a slope of 1/3, so that's not right. So it's B because we needed a y-intercept of 2. Okay, so 17 and 18 are pretty similar. Okay, I think I'll do 18 because 17 already has the inequalities there for you. So it says here Bruno can only run up to, so up to 8 miles. Okay, so that means it's less than or equal to 8 miles per hour. And then run up to 4 miles. So again, that is less than or equal to 4. Okay, so we need it to be shaded to the left or below because we don't know which one's which. To the left or below 8, and then to the left or below 4. Okay, so this one here, this is the 4, it's shaded above, so that's a greater than. So that's not it. This one here on the 4, it's shaded to the right, that's a greater than, it's not that. C, it's shaded below 4, that's what we wanted. And it's shaded to the left of 8, so less than and less than. Less than 8, less than 4. That works. Okay, let's check out D. So we got less than 8, that works, but then the 4, it's above 4. So that one doesn't work, okay? So I can give you a problem like this, even though I didn't give you the inequalities, and you should be able to figure out, even though we don't know which one's the X and which one's the Y, just by knowing that they're both less than, or both greater than, or a combination of them. All right, so have fun with it.